Recording number 8 here, we're going to actually go over the outline and see if we can do some computations actually on this. So it says the F ratio, variance between groups over variance within. A, it says variance between group. That really reflects the treatment. We want that number to be large because that means your drug or whatever you have really worked. Variance within group reflects error. You want that number to be small. You want the scores within a group to be close to each other. Let's look at some example outputs then from this. Let's say that you put all your numbers in, and we're going to do some computations here, and at the end your F score is 1. Would you be happy or sad if your F score was 1? Well, hopefully you would argue that if your F score is 1, that means the variance between the groups is actually equal to the variance within the groups. So that means your treatment effect equals your error. Is that good? No. If you get an F score of 1, that basically means that your study did not work. You'll get a non-significant result. F scores of 1 basically means your study didn't work. How about an F score less than 1? What would that say? Well, if your F score is less than 1, that could mean that the variance between groups is 10, the variance within groups is 20. That wouldn't be a good thing either, would it? That would mean you have more error than treatment. So F scores less than 1 are particularly bad. What we really want, and they'll tend to be more significant, are F scores much greater than 1. If you get an F score much greater than 1, well, your variance between group might be 100, your variance within might be 20. F score 5, now that would be good. So what we really want are F scores that are much greater than 1. Now what we're going to do, believe it or not, is we're actually going to do the computation for the problem that I've described. You have one independent variable, group or condition, 2 levels, drug and no drug, and a DV of memory scores, and we can actually do the computation here. So notice that it's an F score. The variance between groups is the first part. We're going to try to get a number for the variance between groups, then we're going to get a number for the variance within group, and then we're going to divide the two and get our F score. So let's actually start off. Computational analysis. Variance between groups. In order to get the variance between groups, you must get the sums of squares between groups over the degrees of freedom between groups. Remember variance? Variance equals sums of squares over df. So we're just going to now need to do this for variance between groups. I'll show you how to do this, and hopefully you can learn. Formula for the sums of squares between group. Now your book has formulas, but they're more computational formulas. I don't want to teach you that way. I like to use the definitional formulas so you can kind of see where things come from. Boy, that's a mouthful there, right there, isn't it though? Formula for sums of squares between group. It's the summation of n times the quantity x bar minus x bar bar squared. Holy Toledo. What is x bar? Well, you have 2 x bars in this situation. X bar represents your mean for each group. What is the mean for the first group? 2. What is the mean of the second group? 6. X bar bar. X bar bar represents the grand mean. And in this case, what is the grand mean? Well, the grand mean of 2 and 6, x bar bar is 4. So what you need to do is you need to do this for each particular group mean. So the math would be 3, which is n, times the quantity. The first x bar is what? 2 minus 4 quantity squared, plus, you need the other group as well, 3 times the quantity, 6 minus 4 quantity squared. If you do the math for that, 2 minus 4 squared is 4, times 3 is 12, plus 3 times the quantity 6 minus 4 squared is 12. So you should get, and always label things, the sums of squares between group equal to 24. Did you see how that was done? 3 times the quantity 2 minus 4 squared plus 3 times the quantity 6 minus 4 squared. Notice what happens if you ever get a negative value for variance between group. You know you've done it wrong. So the variance between group will be sums of squares between group is 24. Now the next thing it says in the outline, you need the degrees of freedom between group. The way you get that is you say, how many groups do I have? 2 minus 1 is 1, so the degrees of freedom between groups is 1. So what is the variance between groups? Variance between groups equals sums of squares between groups, 24, over degrees of freedom between groups 1. So the variance between groups is 24. That is your numerator for your F-score. So you got half of it. I hope that made some sense to you. If not, listen to the tape and rewind. I'm becoming a little punchy here, but who can blame me? Next, what do we need to do? Well, we got the variance between groups. Now we need to get the variance within group. How do we do that? To get the variance within group, you have to take each score minus the group mean. So each score. So let's start with group number 1, the 1, 2, and 3. Each score, well, you need each score minus x bar. So what is x bar for the first group? Well, x bar for the first group is a 2. So the way you need to do this is in parentheses 1, the first score, minus its mean, 2 squared, plus 2 minus 2 squared, plus 3 minus 2 squared. Do you see that? That's the sums of squares within group for the first group, but then you need to do the same thing for the second group. What's the first number for the second group? You make a parentheses, 5 minus 6 quantity squared, plus 6 minus 6 quantity squared, plus 7 minus 6 quantity squared. What do you get for all that? Well, you get 2 for that one, so the sums of squares within groups, within group 1 and 2, when you add them up, you get a total of sums of squares within group at 4. Now what you need to do, that you have the sums of squares within group, you need to figure out the degrees of freedom within group. Well, the way you do that is you say how many people were in the first group? 3. So you have 2 degrees of freedom there. df equals 2. And how many people do you have in the second group? 3 in there as well, so df2. So the degrees of freedom within group, you have to add those 2 up. 2 plus 2 equals 4. The other formula you can use is the number of groups, k, 2, times n minus 1, 3 minus 1. You also get 4. So the sums of squares within group is 4. The degrees of freedom within group is 4. So what is the variance within group? Hopefully you put 4 over 4 and you get a value of 1. Are you ready to get your F value now? Hopefully the answer is yes. The F value, the variance between groups, reflecting the treatment, is 24. Is that good? Yes. How about the variance within groups? That value is 1. So you get an F score of 24. And the question is that good? Well, we can go into the back of the book, but hopefully an F score of 24 is good. Let's see if they actually... it looks like there's a table 12.3. It doesn't have enough in it. We go to the back of the book, and we find an F table there. And what they need you to do in that F table, I'm just going to use version 9, or not. Looks like F distribution. If you look on, it looks like 705 of version 9. You need degrees of freedom for numerator. So how many degrees of freedom for the variance between group? Well, we had 1. How many degrees of freedom do we have for the variance within group? That's the denominator. That one we had 4. The critical score, hopefully you can see on there, for the 0.05 level is 7.71. So if you look at this, you can see this result is statistically significant. And the way you write this out is you write F, and then in parentheses, 2 things in parentheses, degrees of freedom numerator, which is what? 1, comma 4, close parentheses equals 24, and in this case you can generally write out p less than 0.05. So this result is statistically significant, and it shows that our drug helps improve memory. Hopefully this makes sense and you can figure this out. I'll stop it right there.